If you don't remember reference angle from last year, here it is. A reference angle is an angle in standard position. So theta is in standard position. Its reference angle is the acute angle formed by the terminal side of your angle and the horizontal axis. It's basically the angle between the x-axis and your terminal side. Okay? And please note that it says acute. It will always be less than 90. Why do you think it's important that it is an acute angle? Why do you think it's important that it's acute? What can we make with acute angles? Okay. What kind of angles are in right triangles other than a right angle? They're acute, okay? If our reference angle is acute, we can use it to make a right triangle, okay? That's the point of it being acute, okay? We will use reference angles to help us evaluate angles that aren't acute. Evaluate trig functions of angles. Okay, so first we need to practice actually finding reference angles. Now, degrees you're always going to be more comfortable with, I know, but we need to be able to do this in radians as well. So let's think about our coordinate plane. We're always going to have to be our reference angle is always going back to the x-axis, okay? So in degrees, this is 0 degrees, this is 180 degrees, and then here we are back to 360 degrees. Our reference angles are always going to be from the angle to the x-axis, so these are the values that are going to help us find the reference angle. Okay, let's talk about radians. At the x-axis, this is 0 radians. This is how many? 1 pi, and then all the way back around is 2 pi. All right, so let's practice. We're going to find the reference angle of all of these. Okay, so first let's start with 325 degrees. What quadrant does 325 degrees lie in? The fourth. Okay. So here's our angle, 325 degrees. The reference angle is the acute angle between the terminal side and the x-axis. So that would be this distance right here. Okay. How do I figure out what angle measure that is? Okay, if I look at our picture, all right, the blue and the red angle makes 360 degrees, don't they? So I can take 360 degrees and subtract 325 degrees to get and that is our reference angle. All right, 2.3. Where's that? Is this in degrees or radians? It's in radians. Okay, So 2.3 radians, where would that lie? It's not in the first quadrant. It's in the second quadrant. Okay? Over here, this is pi radians, isn't it? Well, what's pi? 3.14, correct? This is pi over 2. What's half of 3.14? Well, it'd be a little bit more than 1.5, right? If this is a little bit more than 3, this is a little bit more than 1.5. Do you agree? So 2.3 would have to lie somewhere in here. Okay. Is everyone okay with how I figured out that 2.3 was there? Okay. So our reference angle from our terminal side to the x-axis would be here. Okay. How am I going to figure out what that reference angle is? Right, okay, notice how these two angles form a line, right? They're supplementary. So if these would add together to be pi, I can take pi minus 2.3 to get the measure of our reference angle. So what's 3.14 minus 2.3? What? Do you agree? Mm. 0.84? Is that better? Okay. Third example, negative 3 pi over 5. Where is negative 3 pi over 5? Negative though, correct? So it should be in the third quadrant. Because we're going to rotate in the negative direction, correct? So this would be negative pi over 2 and negative pi. So negative 3/5 pi would be about here. Do you agree? Okay. So the angle between the terminal side and the x-axis would be here. Okay. Also note that your reference angle will always be positive and acute. The point is so that we can make triangles with these. So they need to be acute and positive. All right. So at this point, we can forget that our angle was negative. Okay. The angle measure gets us the picture. All right. So let's not worry about the negative anymore. Okay. How am I going to find this red angle? How am I going to find this reference angle? Pi minus 3 pi over 5, right? If I look at these two form 180 degrees or pi. So if I take pi minus the 3 pi over 5, I should have this angle right here. Well, what is 1 pi minus 3/5 pi? 2/5 pi. Any questions about reference angles? No? Is that okay? All right. Remember this. What's your acronym to remember it by? All students take calculus. So what does it mean? Okay. These out of sine, cosine, and tangent, these are our positive trig functions. So all three are positive in the first quadrant because x and y are both positive. Only the sine is positive in the second quadrant because our y coordinate is positive. Only the tangent is positive in the third quadrant because x and y are both negative. And cosine is the only one positive because our x coordinate is positive. All right. Now, what does that mean about our other three trig functions? If sine is positive, what else is positive? Cosecant. If tangent's positive, then also cotangent. If cosine's positive, then also secant. Okay? All right. So keep that tucked away. We're going to have to reference that every now and then. Okay? All right. Negative 3, 4 is a point on the terminal side of an angle theta. Okay? I want the sine, cosine, and tangent of this angle. Okay? So first of all, we should probably do what? Draw a picture. Okay? So here is our coordinate plane. The coordinate negative 3, 4 is right here in the second quadrant. So we have this angle. Here's our angle theta. Okay. If we are going to evaluate sine, cosine, and tangent, okay, the x coordinate is only this cosine ratio on the unit circle. Okay, this does not have a radius of 1, so that cannot work. Okay, so the only way to get our sine, cosine, and tangent ratios is to actually have a right triangle to work with. Okay, well, that is an obtuse angle. How do I create a right triangle? With a reference angle. Okay, so we're going to create a reference triangle here. We're going to use this little reference angle to help us. Okay, so let's label the sides of our triangle. What do we know about our triangle? This is 3 and this is 4. Okay, which means our hypotenuse is 5. Okay, now we're going to take our reference triangle and we are going to create our ratios. Now, we know that some of these are going to be positive and some of them are going to be negative. You can do this one of two ways. You can either say, hey, this is in the second quadrant, so I know that only the sine is positive. And so I'm going to make cosine and tangent negative all just right away. Okay? Or if you'd like, you can label this as a negative 3 because you went to the left 3. Now I know that's not the length of the side of the triangle, but if that helps you keep straight which trig ratios are going to be positive or negative, that can help you. Okay, so now our sine ratio, opposite over hypotenuse, 4/5. Our cosine ratio, adjacent over hypotenuse, negative 3/5. See how that negative would help me? Okay, with my picture. And then our tangent ratio, opposite over adjacent, negative 4/5. That's all you have to do. Okay, really once you get the picture drawn and draw your reference triangle, then it's just the easy SOHCAHTOA. you're going to have some problems like this in your homework. You're also going to have problems like this. Okay. Given that the tangent is negative 5/4 and the cosine is positive, find the other 5 trigonometric functions. So first of all, I see that the tangent is negative. Which 2 quadrants is the tangent negative in? I disagree. Yeah, no, I agree. Sorry. The tangent is negative in the second and fourth quadrants. Oh, you can't even tell it's a 4. Sorry, guys. Where is the cosine greater than 0? What does that just mean? Okay, where is the cosine positive? Cosine is positive in the first and the fourth quadrant, which means what quadrant is theta lying in? Okay, so theta lies in quadrant 4. So let's draw our reference triangle in quadrant 4. Okay, our tangent ratio is 5/4. So opposite over adjacent is 5/4. What should we now do with our picture? We need the hypotenuse. A squared plus B squared is C squared. How long is our hypotenuse? It is radical 41. Okay. So we need the sine, cosecant, cosine, secant, and cotangent of theta. Okay, well, if tangent is negative 5/4, what's cotangent? Negative 4/5. Okay. I also know, okay, tangent was negative. We know cosine's positive. What kind of sine value should sine be? Negative. Okay. What is the sine ratio? Okay, the ratio is 5 over radical 41, right? So we would have to rationalize to 5 radical 41 over 41. Please do not take this fraction and flip it and then re-rationalize, okay? If our sine ratio was 5 over radical 41, then our cosecant ratio is going to be radical 41 over 5. Don't do more work than you need to, okay? Our cosine ratio would be what? Okay, our ratio is 4 over radical 41, so we would have to rationalize it to 4 radical 41 over 41. Do not flip that to get the secant, okay, because we had to rationalize it. Flip the unrationalized version. Secant is hypotenuse over adjacent, so radical 41 over 4. Okay. Please be careful with your positive and negative sine values. Okay. Some of you are going to get really excited about these problems and find all of your ratios and forget to check whether it should be positive or negative and miss some points. Please don't do that. Okay. All right. Last set of questions. We're going to evaluate these without our calculator. Why are we evaluating these without our calculator? Because they are special angles. We can use our unit circle. So first of all, 4 pi over 3. Where is that? That's in quadrant 3. What is our coordinate at 4 pi over 3? Okay. Our reference angle would be pi over 3, correct? 60 degrees. So we know it has to be 1/2 radical 3 over 2. Quadrant 3, they're both negative. So what's the cosine of 4 pi over 3? Negative 1/2, because that's the x-coordinate. Negative 210 degrees. Where's that? Negative 210 would be in quadrant 2. Negative 210 degrees would be the same as what positive angle? Do you agree with Joey? Negative 210 is the same as 150. Okay, right? Negative 210 just looks like that. Right? Okay, so what is our coordinate at 150 degrees?
Negative radical 3 over 2 and 1/2.
Okay, so to evaluate the tangent, we are going to take y over x. 1/2 divided by negative radical 3 over 2. Okay. When you do the division, what happens with the 2's? They cancel. So you have negative 1 over radical 3, which is the same thing as negative radical 3 over 3. Okay. 11 pi over 4. Where's that? Quadrant 4? $11 pi over 4 is the same as what angle?
No, sorry. 45 degrees.
Well, let's talk about an angle between 0 and 2 pi. Because this is more than 2 pi, isn't it?
Yeah.
It's not? How do I find its coterminal angle? Subtract 2 pi. When we subtract 2 pi, 11 pi over 4 is minus 2 pi is what? This is the same as the cosecant of 3 pi over 4, which is where? Second quadrant. Okay? 11 pi over 4 would look like this, right? Okay? Our reference angle would be 45 degrees, or in this case, pi over 4. What's our coordinate on the unit circle? And x is negative, correct? Cosecant the reciprocal of sine. So when we take the reciprocal of radical 2 over 2, we get radical 2. Any questions? Here's your homework. Reminder, I'm doing a homework check for the 5 assignments that you've had. Monday, Tuesday, Thursday you had book assignments, Friday you had a worksheet, today you have a book assignment.